Hi there. I'd like to introduce my research titled by study on predictive deep reinforcement learning for isolated intersection signal control. We know the traffic signal lights can ensure our safety by separating vehicles come from different directions. However, unappropriated control might bring much more waiting time without considering the real-time demands and future prediction. To address this problem, the study proposed a predictive control framework using deep reinforcement learning, which can learn the incoming traffic situation in real-time conditions and produce traffic-responsive signal plan. To get into detail, let's start from defining the traffic signal control itself. As aforementioned, the traffic signal can separate the conflicted traffic by setting such phases. A phase means to determine which direction's vehicle could be under permission. The control problem could be described as to determine the phase and its phase duration. The target of signal control is to serve the real-time coming vehicle as effective as possible. To this end, reinforcement learning might be a good choice that can learn the real-time traffic as the state variable. Then it can react the traffic with the trainable policy that produce appropriate control logic as action. We can also set any control performance as reward for learning machine that can make the learning process following our target. In this study, the coming vehicle number of each entering approaches is taken as the indicator of real-time traffic demand. The action to choose an appropriate next phase, and the reward is set as the total number of vehicles inside all the entry approaches. Some may ask the key word predictive in my title. A traditional reinforcement learning assumes traffic state transition as a Markovian process. They're not realistic due to the fluctuation of incoming demand and control logic. So, in this study, we predict the next step traffic state by queue estimation model, including input-output model and shockwave model. This design could be treated as a combination of data-driven idea and knowledge-driven thinking. To validate the proposed methods, we conduct the simulation experiments with Sumo and compare our method with both traditional reinforcement learning and engineering methods. Through the experiment, we found our method has better robustness for demand increasing, and due to our predictive design, the learner can have faster adaptation for the traffic. For consequence research of this work, I also extend our method to the audio control and general network control. You can subscribe to my Google Scholar page for more updating information. Thank you for listening.